So this next one I'm classifying as sort of a fun one. They're a little bit tricky, and there is a trick to working through these next couple that I wanted to show you. So the one that we've got here, the integral of x to the power of 5 times e to the power of x cubed dx, especially based on the ones we've done before. If we go back a few examples, we did this one, x e to the 2x, and that was a relatively straightforward integration by parts. So we might think, and this is not going to work out, but just so you can kind of see how it doesn't work out, we might be inclined to say, well, I'm going to let my u be x to the fifth and my dv be e to the power of x cubed dx. Now we have no problem getting our du, which in this case would be 5x to the fourth du. But the way we get that is by taking the integral of e to the x cubed dx. And unfortunately, we don't have the means to integrate this using standard integration techniques. So unfortunately, this isn't going to work. So what I would note, though, is that if this had an extra, let's say, x squared with it, if there was an x squared factor here, like maybe out in front of it, we would be able to work this using u substitution, because we could let u be x cubed, and then our du would be 3x squared, and we'd be able to do that. So proceeding with this problem hinges on our ability to recognize that we could handle the step of finding v if there was an x squared out in front of this. We could do it by u substitution. All right. So with that in mind, let's scrap this because this didn't work out, and see if we could maybe approach this a different way. So again, recognizing that the trouble spot here is the integrating of e to the x cubed, what if we were to take this and rewrite this as the integral, because we've got 5 x's, 5 factors of x right here, and this e to the x cubed, in order to integrate, would need an x squared with it. So we're going to break up that x to the fifth. So if we were to call this x cubed times x squared times e to the x cubed dx, so I haven't done anything except split up the x to the fifth into x cubed times x squared. If we were then to say, how about I let this be my u, and I let this be my du now, actually my dv. Let's see if that'll work out for us. So if we bring this off to the side, if we say now I'm going to let u be x cubed, and I'm going to let dv be x squared e to the x cubed dx. So again, du is not an issue. That's just going to be 3x squared dx. And now integrating to get v, we can do this as a substitution problem. So I'm going to let you guys work that on your own, but if we were to use u substitution here, what we would end up with, well, actually let's just go ahead and do that. So this u sub problem if we were to let, and again, since we're doing a u sub in integration by parts, I'm going to call this just a w. So if I was to let w be x cubed, dw would be 3x squared. And we don't have a 3, so if we divided both sides by 3, we'd get 1/3 dw is equal to x squared dx. So now we're going to do the u sub on this integral right here, do the w sub, and call this 1/3 times the integral of e to the power of u du, which is just going to give us 1/3 e to the power of u, which is just going to give us 1/3 e to the power of x cubed. So that becomes our v. So this little u substitution here that we did, that gives us our v, which is 1/3 e to the x cubed. All right, so now we've got all of our pieces to complete integration by parts. Again, we had to split up our original integral in order to integrate dv to get v using the substitution method over here. All right, so let's get back to our original problem. So this integral will be u times v, so 1/3 x cubed e to the x cubed, minus the integral of v du. So that would be 1/3 e to the x cubed v times du 3x squared dx. So if we clean this up a little bit, we'll get 1/3 x cubed e to the x cubed. And then this 1/3 and this 3 will multiply to give us 1, and we'll just have minus the integral of x squared e to the x cubed dx. Now, you may be looking at this integral and say, wait, do I have to integrate this again? Yes, we do. However, we just integrated it over here. It was the exact same thing. We used the substitution method to integrate this. It was the exact same function right up here. We'll be started off with our du. So in this case, we can just kind of carry over the work that we've already done. So we'll just make a note. We just did this. And now we'll get our solution. So we'll have 1/3 x cubed e to the x cubed minus, and we know that this worked out to be 1/3 e to the x cubed plus c. And then, we could factor this theoretically, but we can just call that our final answer. All right, so kind of be on the lookout for problems like this, where maybe the use of the integration by parts may not seem like it works at first, but if there are an excess of x's in the original integrand that we might be able to pull over and make a u substitution work, just kind of keep your eye out for that type of problem.